When considering the best environment manager for your AI and deep learning projects, the choice often comes down to Anaconda versus Miniconda. Both are powerful tools that simplify package management and deployment, but they have a few key differences that might influence your decision, especially as you think about efficient resource usage, ease of setup, and flexibility in your workflow. Anaconda is the full-featured distribution, offering a robust suite of over 1,500 scientific packages curated for data science, machine learning, and artificial intelligence tasks. Installing Anaconda means you get Python, Conda, and the most common packages like NumPy, Pandas, scikit-learn, Jupyter Notebook, TensorFlow, PyTorch, and more, all pre-installed and ready to use. This can be a great advantage for beginners or those who want to get started immediately without worrying about compatibility issues across packages. Miniconda, on the other hand, is a much lighter installer. It includes only Conda, Python, and their basic dependencies. You start with a minimal setup, then fill it in with just the packages you need as your projects demand. If disk space, download time, or maintaining a lean environment is important to you, Miniconda is likely a better fit. You avoid unnecessary packages and gain more control over versioning and dependencies, which, in fast-moving fields like AI, can help ensure consistency and reproducibility. When selecting between the two, consider the following rule of thumb. Use Anaconda if you value convenience and need a pre-packaged selection of scientific tools, especially in educational or prototyping settings. Go with Miniconda for more custom, production-oriented environments, or when you want to minimize storage space, start from scratch, or avoid package bloat. Regardless of your choice, Conda remains the foundation. Conda is an open-source package and environment manager tool that handles package installation, dependency management, and environment isolation. Whether you use Anaconda or Miniconda, your basic workflow will be the same, creating virtual environments specifically tailored for each of your AI or deep learning projects. Let's walk through the general setup flow and command line basics, which apply whether you choose Anaconda or Miniconda. Begin by downloading the installer from the official website. For Anaconda, visit annaconda.com and select the distribution appropriate for your operating system, Windows, Mac OS, or Linux. For Miniconda, head to docs.annaconda.com and find Miniconda's download links. Choose the Python version you'd like to start with, typically the latest, as most frameworks maintain compatibility with recent releases. After downloading, follow the installation instructions for your system. On Windows, run the executable installer. On Mac OS or Linux, open your terminal and run the bash script provided. Make sure to allow the option to initialize Conda for your shell environment during setup so that Conda commands are recognized every time you open your terminal. Once installed, you'll want to update Conda itself to ensure you have the latest features and bug fixes. Open your terminal or Anaconda prompt and type Conda update Conda. You'll be prompted to confirm. Type Y to proceed. Now you're ready to create your first virtual environment. A virtual environment is an isolated space on your system where you can install Python, Conda packages, and libraries, segregated from the global Python interpreter and other environments. This isolation prevents conflicts among package versions and allows you to create reproducible setups for different projects. Say you want to create a new environment for deep learning using Python 3.10. Run the following. Conda create. Name deep learning Python 3.20. Here, deep learning is the name you assign to your environment. You can choose any name. Pick something meaningful related to your project. After the environment is created, activate it by running Conda activate deep learning. Your command prompt will change, displaying the name of your active environment. This ensures that all subsequent installations and Python executions use the context of this virtual environment. Now, you can begin installing the essential libraries and frameworks needed for AI and deep learning. Conda supports a vast array of packages, and if operating within the Anaconda distribution, you'll have many already installed. But with Miniconda, or if you're customizing beyond the defaults, you can install packages as needed. To install NumPy, Pandas, and matplotlib, For data manipulation and visualization, run conda install NumPy pandas, matplotlib. If you're focusing on deep learning with TensorFlow, use conda install TensorFlow. Or for PyTorch, visit pytorch.org to get the most recent recommended install command, as it often includes specific instructions depending on your operating system, Python version, and whether you want GPU acceleration. Typically, for the CPU version, it might look like conda install PyTorch, Torch Vision. Torch audio keep you only, see PyTorch. For GPU-enabled installations, pay careful attention to CUDA version compatibility. Installing the appropriate CUDA toolkit, NVIDIA's platform for GPU-accelerated computing, is crucial for harnessing the power of GPUs for training large-scale deep learning models. Conda can often handle these dependencies for you. Conda install PyTorch, Torch Vision Torch, Audio PyTorch. CUDA 11.8, C PyTorch, C NVIDIA. Replace E11.8 with your desired CUDA version based on your GPU and driver. It's also common to use Jupyter notebooks for prototyping and experimentation. To install Jupyter Lab, the next generation Jupyter interface, type conda install Jupyter Lab. Once installed, run Jupyter Lab. This will start a new notebook server, and your browser will open, ready for interactive coding and visualization. When you're working on multiple projects, especially in AI, versions of libraries can differ dramatically. Using isolated conda environments allows you to maintain precise sets of dependencies for each project. For example, perhaps one project needs TensorFlow 2.4, while another requires PyTorch 1.13. Each environment can have a unique combination without interference. Creating a second environment for an NLP, natural language processing project, you might use conda create, name NLP Python 3.8, conda activate NLP, conda install space NLTUC. If you want to export the list of packages in an environment, for example, to share with a collaborator or to reproduce your environment on another machine, use conda inv export environment YML. This creates a YAML file describing the environment, including Python version and installed packages. To recreate an environment from this file, use conda inv create f environment YML. In addition to conda packages, you may sometimes require packages that are only available through pip, Python's package installer. While it's best to use conda when possible due to tighter dependency control, pip can be used within your active conda environment. Pip install some package. Be sure to activate your environment first to keep these pip installed packages separate. Anaconda users may appreciate Anaconda Navigator, a graphical desktop application that allows you to manage environments, install packages, and launch applications like Jupyter Lab or Spider without command line interaction. While powerful, many practitioners prefer the command line for fine-grained control and scripting purposes. If you want to see a list of all environments you've created, type conda inv list or conda info.invs. You'll see the paths to your environments with an asterisk next to the currently active one. To remove an environment when you no longer need it, deactivate it first, conda deactivate. Then delete with conda inv remove, name of environment. Over time, package versions and dependencies change. It's wise to periodically update packages, conda update package name, or to update all installed packages, conda update all. Be cautious though, as updating all can sometimes introduce incompatibilities if not managing dependencies carefully. Miniconda's minimal starting point means you add only what you need, avoiding unused packages and keeping your environment lightweight. This is especially beneficial when deploying applications to production, setting up CI/CD pipelines, or working with limited storage resources. The flexibility to select each package version is also valuable for research, where you may wish to test your models against different versions of deep learning libraries to verify reproducibility. Anaconda's comprehensive starting point smooths the learning curve at first. helping beginners avoid the hassle of tracking down and resolving complex package dependencies. However, this comes at the cost of a larger initial download and a more disk-intensive environment. For many educational, research, or exploratory projects, the convenience of pre-installed packages outweighs these costs. Whatever you choose, both approaches share the foundational benefit of Conda's environment isolation, protecting your system against package conflicts and providing templates for repeatable workflows. Before wrapping up, let's summarize the key command lines and steps. 1. Download and install either Anaconda or Miniconda from their official sites. 2. Open your terminal or Anaconda prompt. 3. Update Conda to the latest version by running conda update conda. 4. Create a new environment with conda create. Name envname python x.x. Replace envname and x.x with your desired values. 5. Activate the environment using conda activate envname. 6. Install required packages using conda install package 1 package 2. 7. For pip-only packages, use pip install package after activating your environment. 8. Use conda env list to see all environments and conda deactivate to leave an active environment. 9. Share or reproduce environments using conda env export and conda env create.f environment.yml. 10. Remove environments you no longer need with conda env remove name envname. By integrating conda environments into your workflow, whether via Anaconda for all-inclusive convenience or miniconda for a custom, minimal approach, you set yourself up for a reliable, upgradable, and replicable experience in AI and deep learning. Experiment freely, confident that you can keep your project dependencies precise and your systems uncluttered. Choosing between Anaconda and Miniconda isn't a matter of right or wrong, just one of matching your tools to your goals, your constraints, and your comfort level. Both will serve you well in your journey into artificial intelligence, machine learning, and beyond.